Hello, and welcome. I'm Vrushali Milky, studying at JDCOEM Nagpur, in 3rd semester 2nd year, and today we're diving into a core concept of object-oriented programming, inheritance in Java. We'll specifically focus on derived class structure and the difference between overriding and extension. Here's our roadmap for the presentation. We'll cover everything from the basic syntax of inheritance to the complexities of the JVM dispatch flow in a practical, real-world scenario. Let's get started with the basics. Inheritance allows a subclass, or derived class, to inherit fields and methods from a superclass, or parent class. This principle promotes code reuse and defines a strong, is a, relationship, as a dog is a type of animal. The core syntax to achieve this is the extends keyword. Let's see this in a simple Java example. Here, the animal class has a generic speak method. When the dog class uses extends animal, it automatically inherits that speak method. The dog class doesn't need to write the method again. A derived class object includes the data inherited from its superclass. Proper initialization is handled by constructor chaining, which ensures the superclass part of the object is set up first. You use super arguments to call the parent's constructor and the super keyword to access its fields and methods. This code block shows derived structure clearly. The car class uses super type in its constructor to invoke the vehicle class's constructor. Later, the show details method uses super display type to explicitly call the superclass's method implementation. This is a crucial distinction. Overriding redefines an inherited method for specific subclass behavior, which is how we get runtime polymorphism. Extension is much simpler. It just adds new methods unique to the subclass, expanding its capabilities without changing the parent's logic. Overriding must follow strict rules. The method signature, name, parameters, and return type must be an exact match, and the access modifier must not be more restrictive. You should always use the @override annotation to ensure you're overriding correctly. Also, remember that static or final methods cannot be overridden. Here's our overriding example. The generic animal, make sound, is redefined in both dog and cat using the @override annotation. This allows a single method call, make sound, to execute different logic based on the actual object type at runtime. This is polymorphism in action. Extension is for adding entirely new functionality. Since these methods don't relate to the superclass, they have no method signature constraints. They simply enhance the subclass's specific behavior and are only accessible via a subclass reference. In this code, the circle class extends shape and adds a brand new method, calculate area. This method is unique to the circle and is not part of the shape contract, successfully extending the circle's functionality. The Java virtual machine uses two flows. Static dispatch resolves the method call at compile time, based on the reference type. Dynamic dispatch, however, is for overridden instance methods, resolving the call at runtime based on the actual object type. This is the mechanism behind runtime polymorphism. Inheritance offers great benefits like code reusability and polymorphism. But watch out for common mistakes, such as the misuse of the is a relationship or forgetting a required super call in a subclass constructor. Think about a banking system. The generic account is the superclass. Savings account and checking account are derived classes that override the withdraw method with different rules and extend functionality by adding unique methods like add interest or process check. That brings us to the end of our session on derived class structure, overriding, and extension in Java. Thank you for your time and attention.